We continue our investigation of analysis of variance. Now we're going to begin looking at degrees of freedom, matching them up appropriately with sums of squares as we've looked at in other videos. And then we're going to derive the mean squares and the F ratio. So we can start with the concept of variance. We can think of the numerator of variance as our sums of squares, and the denominator of variance as the degrees of freedom. We can see here S squared for variance for a sample, and our typical sums of squares, in this case y representing our variable, and the denominator we have n minus 1. We can think of that n minus 1 as our degrees of freedom, the number of things free to vary in our data. So for example, if we had a data set, a very simple data set, with the values of 1 and 2, the third value being unknown, but we knew the mean to be 2, in order for all of those to be true, that last value must be 3. So in order for the mean to be 2, our y values need to be the values of 1, 2, and 3. And that's a simple way of thinking about degrees of freedom. They get more complex as we go on, but this concept should remain the same. Variance and analysis of variance. So when you hear the word mean squares, effectively this is a variance estimate. So just translate that in your head where you see MS. This is an estimate of our variance, and it's going to be weighted. Instead of just doing the sum of squares by n minus 1, we're going to have different types of sums of squares that we're going to partition, and they're going to be divided by the appropriate degrees of freedom. So we can visually see sums of squares divided by degrees of freedom, just like the sums of squares in our variance divided by n minus 1 is equal to some form of variance estimate, which we're going to call MS. So we could start with what we had done previously. This builds on the analysis of variance 3 mini lecture. We have the source of variation. We can have between group variance, within group variance, and the total variance. And then we have different ways of breaking it up. Our sums of squares between is the difference between group means and the gram mean sums of squares. The sums of squares within is the difference between an individual and their individual group's mean, summed across, of course, over all of the groups. And finally, the total sums of squares is the typical sums of squares you may think of. This could be thought of as every person, regardless of group, how far away they are from the grand mean or the mean of means. And that's discussed in the previous short lecture. Now that we have recapped sums of squares, let's talk about degrees of freedom. We have different degrees of freedom for our sum that are going to be associated with our sums of squares. For between groups degrees of freedom, we can simply see that there are a certain number of groups. We'll call that J minus 1. So if there are 4 groups, then we would have J, which is 4, minus 1, which would equal 3. So it's the number of groups minus 1. And if we think about what we were doing in sums of squares, we were taking the group mean, and seeing how far away it was from the grand mean. So if there were 4 group means, we would have 4 things, and if we had the grand mean, we would have a 5th thing, which, as we saw before, or as I discussed before, and as in our class presentation, that gives us one thing that's free to vary. If we knew 3 of those group means and we knew the grand mean, the last group mean would already be determined. So that's degrees of freedom for between group. For within, we have a total number of observations minus the number of groups. Well, for each group, we effectively have n minus 1 degrees of freedom if we were just to look within each group. So as a total, we have n minus j, j being the number of means that are associated with the group. So if we have 4 group means, then we have j as j would equal 4. So putting it together, our degrees of freedom for between group was j minus 1, number of groups minus 1. And then we have total number of people, that capital M minus j minus the number of groups. And n minus 1 for total, which is just the total number of people minus 1, gives us what we'll see sort of as an adjusted total degrees of freedom. And I've put the sums of squares here as well that we have reviewed. So we have sums of squares between and degrees of freedom between, sums of squares within, degrees of freedom within, sums of squares total, degrees of freedom total. So now we can use these building blocks to actually begin creating our mean squares in our F value. So our mean squares for between and within, we can calculate by taking the sums of squares between and dividing it by the appropriate degrees of freedom, j minus 1. So our equation, which is really the variance of how things vary between or amongst groups, we see as sums of squares between SSB, subscript b, divided by, I have k minus 1 there, I'll have to fix that on a later slide, but that really should be j minus 1. And then for within groups, we're just taking the sums of squares within, dividing it by the degrees of freedom within, which is n minus k. That k again is equal to the j, so I'll edit that on my next set of slides. Finally, you take the sums of squares between and divide it by the sum of squares within, and we get an F ratio. And that's the calculation of our F value for an observed F. We're going to see in later slides or in class lecture where we'll calculate these out, we'll practice. We're also going to compare that F ratio to, we want to calculate it to what we expect to see, just like we did with our t-test previously.